matrix that is having only one row, at the same time only one column. Suppose matrix 7. What is the specialty? The matrix contains only one element. Suppose A equal to matrix 7. How many rows to this matrix? 1. So it is a row matrix. How many columns to the matrix? Only 1. So it is a column matrix. So what we said, what we are looking for, or what we were searching for a matrix that is a row matrix as well as a column matrix, and our search reached to the answer that a matrix having only one element is a row as well as a column matrix. There is no other situation. So we can generalize, yes, a matrix having only one element is a row as well as a column matrix. There is no matrix with order more than 1 by 1 or with order different from 1 by 1, that is row as well as column matrix. Okay, so from row matrix and column matrix we just came to a speciality. That speciality gave us a matrix containing only one element, and we said the speciality of that matrix containing only one element is it is a row as well as column matrix. Okay, now we just continue with the classification of matrices. We have discussed row matrix, column matrix. Okay, now we come to another type of matrix, that is square matrix. Okay, so in the very definition of matrix, we said a matrix is a rectangular array of numbers arranged into rows and columns. So anyhow, in the very definition, we made use of the geometrical term rectangle, and thereafter we correlated the dimensions, namely the lengths and breadths of a rectangle to which dimensions of the matrix, namely the number of rows and the number of columns. So in short, we have seen that the dimension of a rectangle is equivalent to the order of a matrix. Clear? Okay. So anyhow, in matrix, we just introduced the term rectangle. Okay, and we just think of the simple geometric way that rectangle to square. Okay, we know that rectangle has two dimensions, length and breadth, and we simply know that when this length is equal to breadth, the rectangle becomes a square. When length and breadth are equal, a rectangle becomes a square. So a matrix is a rectangular arrangement. What does it mean? If we simply take any matrix, there is a rectangle. Now in that matrix, length, rectangle means length, the corresponding concept or the thing in matrix is what? Number of rows. And the breadth means what? Number of columns. So what we said, when length becomes breadth, a rectangle becomes square. In the same manner, when the number of rows is equal to number of columns. The rectangular matrix, but no need to say rectangular matrix, we can simply say what? Matrix becomes what? A square matrix. Here, so what we say? A matrix becomes a square matrix when its number of rows and number of columns are equal. That is, a matrix having equal number of rows and columns is known as a square matrix. As I mentioned earlier, the reason for the name square is there in the definition itself. What's the reason? Number of rows means equivalent to length in rectangle is equal to number of columns means what? Breadth. So a matrix having equal number of rows and columns is known as a square matrix. We write an example. So equal number of rows and columns. So we can decide if there is only one row and one column, only one element, that is again which one? A square matrix. 2 rows and 2 columns, 3 rows and 3 columns. Suppose we are writing a matrix with 3 rows. 1 minus 1, 4, 0, 7, 8, 2, 1, 5. Okay, this is a matrix. How many rows? 1, 2, 3. And how many columns? 1, 2, 3. That is 3 by 3. Okay, so this is a matrix with 3 rows and 3 columns. So according to our definition, this matrix is nothing but a square matrix. Okay, and for the square matrix, A, order of A is equal to 3 by 3. Now just remember, when you come to a rectangle, for example, a rectangle of length 4 and the breadth 3, we say a rectangle of 4 by 3. The simple meaning is, we say a rectangle of dimension 4 by 3. Okay, now suppose we are coming to a square with the length 4, then of course the breadth is also what? 4. The meaning is, since it is a square, as we say length 4, the rest of the statement is understood to us, because in a square, length and breadth are equal. So the meaning is what? When we are saying about a rectangle of length 4, we cannot stop the statement over there. The listener is curiously waiting to hear the breadths. The breadth may be different. But when we come to a square, we are saying a square of length 4. Then there is no question, there is no doubt. To every listener, it is clear that the breadth is also going to be 4, because in a square, length and breadth are equal. So in the same manner, when we come to a square matrix, what and what are equal? Number of rows and number of columns. So when we say the order of a square matrix, for example 3 by 3, it is not necessary to say order of A equal to 3. It is enough to say, it is not necessary to say order of A equal to 3 by 3. It is enough to say order of A equal to 3. The rest is understood. The meaning is what? Number of rows and number of columns are equal. So it means that the square matrix of order 3, what does it mean? A is a square matrix with 3 rows and 3 columns. Okay, so we have discussed what is meant by a square matrix, and as we say, it is better as much possible correlate with the geometrical concept, like how rectangle becomes square. Then it is going to be more clear, more concrete to us, because matrix is a new concept for us, but rectangle, square, these are all in our thought, all in our memories, all in our knowledge, right from the 4th or 5th standard. So it is better trying to correlate the new things with the existing things. Then the matter will become more clear and we don't feel it as a new thing. We just feel it as a continuity of our knowledge. Okay. Now, okay, in this we think of a square. Okay, we know that the square has 4 sides, or the 4 sides are equal, and from the sides we know that square has which one? Diagonals. Okay, 2 diagonals. I have drawn one diagonal of this square. Okay, which one diagonal? I can say the diagonal originating from the left top. The other one is from the left bottom. Doesn't matter. One diagonal is drawn. The diagonal from the left top. Okay. So in the same manner, we come to a square matrix. A square matrix corresponds to a square arrangement. Okay. For this square arrangement, also we just consider the diagonal from the left top. The meaning is this diagonal. Okay, and there are 2 diagonals. We are just concentrating because actually these are all mere definitions or the things are introducing for our convenience.